If you lead engineering work, manage projects, or own disciplined delivery, listen carefully. Most engineering failures do not begin at construction. They begin much earlier. They begin when project setup is weak, when the basis of design is unclear, when competency is assumed, when checking becomes mechanical, when interfaces are not actively managed, when design reviews become calendar rituals, and when deliverables are issued because the date has arrived, not because the design is truly ready. That is why today's topic matters. Technical stewardship. And let me be direct. Technical stewardship is not paperwork. It is not a corporate template. It is not another quality document sitting in a project folder. Technical stewardship is the engineering leadership system that protects technical integrity, design quality, safety in design, sustainability, project predictability, and organizational credibility. If you are an engineering manager, project manager, discipline manager, project engineering manager, lead discipline engineer, or technical specialist, this is one of the most important management disciplines you can build into your delivery model. Because good engineers are not enough. Good intentions are not enough. A strong schedule is not enough. A good kickoff meeting is not enough. If the system does not actively protect technical integrity, the project eventually depends on heroics. And heroics are not a management system. A mature engineering organization does not depend on late-night rescue. It depends on early governance. It depends on clear roles. It depends on competent people. It depends on disciplined reviews. It depends on real corrective action closure. It depends on gatekeeping with authority. It depends on lessons learned that actually change future behavior. That is technical stewardship. At its core, a technical stewardship plan defines the minimum technical stewardship activities required for a location, office, project, portfolio, or customer sector group. It defines how engineering work is governed. It defines which systems must be used. It defines who owns technical assurance. It defines when reviews happen. It defines how competency is verified. It defines how corrective actions are closed. It defines how risks are escalated. It defines how gatekeeping prevents immature deliverables from escaping into procurement, construction, commissioning, or operations. And most importantly, it creates a formal bridge between the project execution team and the wider engineering leadership team. On one side, you have the project team, the project manager, project engineering manager, lead discipline engineers, engineers, designers, coordinators, and discipline teams. On the other side, you have off-project leadership, the manager of engineering, discipline chief engineers, technical specialists, quality management, and engineering governance. The project team is close to the work. That closeness is powerful, but it also creates blind spots. Technical stewardship brings independent technical visibility. It does not replace normal design checking. It does not replace discipline ownership. It does not replace project management. It strengthens all of them. It turns engineering intent into engineering control, because intent is not control. Saying we will deliver quality is not control. Saying we follow standards is not control. Saying we have experienced people is not control. Control means the process is defined, the role is assigned, the review is scheduled, the evidence is available, the action is owned, the risk is escalated, and the closure is verified. That is the difference between leadership language and delivery discipline. The first pillar of technical stewardship is processes and systems. All engineering work must be performed through approved engineering systems, project execution procedures, checking requirements, discipline templates, technical standards, quality processes, and management controls. But here is where many projects quietly lose discipline. A team starts with the right system, but pressure slowly creates exceptions. One discipline uses an old template. Another follows a previous project's standard. A designer assumes the customer requirement is the same as the last job. A deliverable list exists, but nobody actively manages maturity. Checking requirements exist, but checking quality varies. A procedure exists, but the project does not apply it with discipline. That is how technical drift begins. The corrective action is simple. Use approved systems, control deviations, approve project-specific changes, and use disciplined task and deliverable plans where project size, risk, complexity, value, or resource capability demands stronger control. A task and deliverable plan is not a startup document. It is an active management tool. It defines what each discipline must produce, how deliverables are sequenced, what checking is required, what interfaces must be managed, what resources are needed, and what level of review applies. Without this, the project can look busy while drifting out of alignment. The schedule may show progress, the dashboards may look healthy, but if the basis of design is incomplete, vendor data is late, interfaces are weak, and checking is superficial, that progress is false progress. And false progress is one of the most dangerous conditions in engineering delivery. The second pillar is organization. Technical stewardship needs visible structure. You cannot govern technical work through vague accountability. At office level, the engineering organization must define the manager of engineering, discipline chief engineers, design leadership, technical specialists, work share coordination, project engineering interface, and quality interface. At project level, the manager of engineering, project manager, and project engineering manager must define the engineering organization appropriate for the project. A small, low-risk project does not need the same structure as a high-risk, multidiscipline, multi-office, technology-heavy project. But every project needs clarity. Who owns technical quality? Who approves technical deviations? Who verifies competency? Who chairs reviews? Who closes review actions? Who escalates unresolved risk? Who can stop a deliverable from being issued? If these answers are unclear, the project is already carrying hidden risk. The third pillar is roles and responsibilities. If everyone owns technical quality, no one owns technical quality. The manager of engineering owns the stewardship system. This role ensures that the technical stewardship plan is prepared, implemented, maintained, and reviewed. It ensures the right organization structure is in place, the right systems are available, appropriate reviews are undertaken, peer reviews are scheduled, corrective actions are agreed and implemented, lessons learned processes are active, and major technical issues are escalated. The manager of engineering also monitors project performance against quality, schedule, and budget, and initiates extra reviews where warning signs appear. That point matters. Technical stewardship is not passive. If a project is struggling with resource gaps, new tools, unfamiliar technology, inexperienced leads, client change, schedule pressure, or quality issues, leadership must increase technical visibility. The project engineering manager embeds review requirements into the project execution plan, coordinates reviews with the manager of engineering, monitors project activity, initiates extra reviews when required, and participates in reviews on other projects to strengthen independence and shared learning. The discipline chief engineer owns discipline quality, consistency, technical leadership, qualified resourcing, discipline review participation, remedial action, and discipline level monitoring. The lead discipline engineer supports reviews by making people available, preparing documentation, supporting review packages, and confirming gate criteria where gatekeeping is used. Technical specialists protect technical integrity in specialist areas. They guide complex technical decisions, mentor younger engineers, and prevent teams from improvising in high-consequence technical areas. This structure matters because project pressure always attacks discipline. When pressure rises, people shorten reviews, skip checks, rely on assumptions, move ahead without closure, and issue with caveats. Clear roles stop this from becoming normal. The fourth pillar is competency. Competency is one of the biggest silent risks in engineering delivery, and managers must discuss it honestly. Competency is not just years of experience. It includes qualifications, technical knowledge, tool capability, system knowledge, code and standard familiarity, checking discipline, interface awareness, risk recognition, escalation maturity, and understanding of consequences beyond the drawing. A person may know the software but not the engineering judgment. A person may know the template but not the design intent. A person may know the standard but not the customer interpretation. A lead may be strong technically but weak in coordination. A checker may be available but not sufficiently experienced or independent. This is why competency must be a standing agenda item in technical reviews. Not as blame, not as politics, as risk management. The question is not, are our people good? The question is, are our people correctly matched to this project's technical risk? If not, leadership must act. Add support. Assign mentors. Use technical specialists. Increase review intensity. Strengthen checking. Do not wait for failure to prove what you already suspected. The fifth pillar is safe and sustainable engineering for the asset lifecycle. A design is not successful because it was issued. A design is successful when it can be built, operated, maintained, inspected, modified, shut down, and decommissioned safely and responsibly. Technical stewardship must protect technical integrity, safety in design, and sustainable design. Technical integrity means the design is correct, consistent, compliant, constructible, operable, maintainable, and aligned with design intent. Safety in design means hazards are identified and reduced through engineering decisions, not transferred blindly to construction, operations, or maintenance. Sustainable design means the asset considers long-term performance, resource efficiency, environmental impact, resilience, and life cycle responsibility. The failure mode is treating safety and sustainability as late-stage review items. That is too late. If access is poor, layout is congested, isolation philosophy is weak, maintenance space is missing, hazardous interfaces are embedded, or materials are poorly selected, late review creates rework. Safety and sustainability must begin at the design basis. Now we come to the heart of the plan. Technical peer reviews. Technical peer reviews ensure the project is positioned for success and that issues are identified early enough for effective correction. For major projects, reviews normally occur around 20%, 60%, and 90% design completion. For ongoing engineering services and portfolio projects, reviews should occur periodically, often quarterly, using representative sampling. Each review asks a different question. The 20% review asks, have we set up the project correctly? The 60% review asks, are checking procedures, coordination processes, and developing deliverables actually working? The 90% review asks, are completed deliverables technically aligned, checked, constructible, and ready for issue? This staged model is powerful because each review protects a different risk point. The 20% technical review focuses on discipline setup. It examines man-hour budgets, staffing, schedule, basis of design, safety in design, job scope, customer requirements, customer standards, interdiscipline coordination, internal procedures, deliverables, level of detail, and discipline readiness. This is where success is often won or lost. If the project setup is weak, every later deliverable inherits that weakness. If the basis is unclear, assumptions multiply. If staffing is weak, quality suffers. If standards are not understood, rework follows. If coordination routines are not defined, clashes appear later. The 20% review asks the hard question, are we truly ready to execute, or are we just moving because the schedule says move? The 60% technical peer review exposes false progress. It evaluates checking procedures, checking criteria, sample check deliverables, accuracy, quality, scope compliance, safety and design, customer requirements, supplier data integration, interdiscipline coordination, squad checking, project status, productivity, milestone completion, and conformance to the project execution plan. A Level 1 review examines procedures, checking approach, coordination, specifications, standards, project objectives, special considerations, master documents, change control, progress assessment, and productivity reporting. A Level 2 review goes deeper by spot-checking drawings, calculations, and deliverables that have already passed checking and back-checking. It looks for deviations that could become expensive during construction. This review tests whether progress is real. A project may claim 60% progress. But are the drawings checked? Are they coordinated? Are they aligned with supplier data? Are they consistent with the design basis? Are cross-discipline interfaces clear? Are changes controlled? Are safety issues resolved? Are calculations aligned with drawings? If not, the project does not have technical maturity. It has document movement, and document movement is not engineering progress. The 90% technical peer review is the last serious defense before construction pain. It examines completed discipline deliverables using random sampling of key drawings, work packages, coordinates, dimensional data, certified supplier data, specifications, calculations, material compliance, material takeoffs, requisitions, and interdiscipline alignment. The purpose is to catch deviations that would be costly to fix during construction or dangerous during operation. Level 1 focuses on drawings and calculations. Level 2 adds deeper review of specifications, calculations, material compliance, material takeoffs, requisitions, supplier data alignment, and consistency across deliverables. The mistake at 90% is assuming that because a deliverable has passed discipline checking, it is ready. Discipline checking may not catch every interface issue, supplier data mismatch, construction sequencing problem, material discrepancy, or inconsistency between drawings, calculations, and requisitions. That is why independent peer review still matters. For portfolio projects and ongoing engineering services, the same stewardship logic applies, but the rhythm changes. These projects may be smaller and repetitive, but they are not risk-free. In fact, portfolio work often creates risk through familiarity. People assume the work is routine. They assume the plant is known. They assume the small job does not need strong review. Slowly, shortcuts become normal. Portfolio reviews must examine sampled projects and the overall program, interfaces with plant personnel, work order processes, work package definition, execution procedures, constructor interfaces, subcontractor interfaces, and site feedback. The key is pattern recognition. If the same issue appears across several small projects, it is not a small issue. It is a system issue. Now let us talk about corrective actions. A review without corrective action closure is theater. It may produce a report, it may satisfy an audit, but if actions are not closed, risk remains. A strong stewardship process records non-conformances, risks, improvement opportunities, near misses, incidents, and lessons. Each action must have an owner, due date, priority, status, evidence, and escalation path. Do not close actions with vague statements. Do not close actions because someone said addressed. Closure must show what changed. Was the drawing revised? Was the calculation updated? Was the design basis corrected? Was the checking process improved? Was the supplier data incorporated? Was the risk register updated? Was the procedure changed? Was the lesson fed back? If you cannot show the change, the action is not closed. Now, gatekeeping. Gatekeeping controls whether key engineering deliverables are mature enough to move forward. Typical gates include issue for front-end engineering design, issue for design, and issue for construction. The principle is simple. If required information is not available at the required maturity, the gate is red. When the information is available and verified, the gate turns green. Only when criteria are satisfied should the deliverable be issued. A red gate is not an inconvenience. It is a risk signal. Sometimes the correct response is to stop work and resolve a serious safety issue. Sometimes it is to use conservative design assumptions with clear mitigation. Sometimes it is to escalate missing supplier data. Sometimes it is to proceed with formally accepted risk. But what you cannot do is pretend the risk does not exist. A gate without authority is decoration. If the gate cannot stop an immature deliverable, it is not a gate. It is a graphic. The final pillar is lessons learned. This is where many organizations waste valuable experience. They collect lessons too late. They write them too vaguely. They store them too passively. Then they repeat the same mistake on the next project. A real lessons learned process collects, analyzes, shares, and implements project engineering feedback. The lesson must change something. A checklist, a standard, a review prompt, a training module, a technical bulletin, a design guide, a gate criterion, a competency requirement, a project setup process. If nothing changes, the lesson was not learned. It was only documented. So here is the sharp management takeaway. Technical stewardship protects against incomplete setup, unclear roles, weak competency, poor discipline planning, false progress, superficial checking, poor interface management, delayed supplier data integration, uncontrolled deviations, weak safety and design, immature deliverable issue, unresolved corrective actions, repeated lessons, and late construction rework. But more than that, it protects engineering culture. It tells teams that quality matters. It tells discipline leads they are not alone. It tells project teams that technical risk can be discussed openly. It tells managers that review closure matters. It tells young engineers that systems matter. It tells clients that the organization is serious about integrity. It tells leadership that engineering delivery is not being left to hope. So ask yourself directly, are your technical reviews scheduled early or negotiated late? Are findings specific or politely vague? Are corrective actions actually closed? Is competency discussed honestly? Are discipline leads supported or quietly overloaded? Are deliverables issued based on maturity or date pressure? Does gatekeeping have authority? Are lessons learned changing behavior? Are you governing technical risk or simply reporting progress? Because in engineering management, hope is not a control measure. A good team is not a system. A review without closure is theater. A gate without authority is decoration. A lesson without implementation is memory loss. And a project without technical stewardship is relying on luck where leadership should be relying on discipline. Technical stewardship is not about slowing projects down. It is about preventing the kind of technical failure that slows projects down much more brutally later. It is about doing the right work at the right time, with the right people, through the right process, with the right level of review. It is about protecting technical integrity. It is about protecting the asset lifecycle. It is about protecting your team from avoidable chaos. It is about replacing late heroics with early discipline. If this message resonates with you, like this podcast, share it with your engineering network, and subscribe to Leadership Notes on YouTube at www.youtube.com/@leadershipnotes for more sharp, practical guidance on engineering management, project delivery, process automation, engineering design, and control automation. Follow my LinkedIn newsletter for deeper articles, technical management frameworks, and hard-earned lessons for managers, project managers, engineering managers, and discipline leaders who want stronger delivery and fewer late surprises. Because the best engineering organizations do not just produce deliverables. They protect decisions. They protect integrity. They protect outcomes. They practice technical stewardship.